Hi, today we are going to see about block diagram reduction techniques, design thinking based. Empathy. The blocks represent different components or subsystems, and the lines show how signals or information flow between these components. The goal of reduction is to simplify these diagrams. Define. It consists of a single block or a combination of blocks. These are used to represent the control system in pictorial form. Signal into the block represents the input and the signal out of block represents output, where input is R of S and output is C of S, while the block itself stands for the transfer function G of S. Flow of information is unidirectional, output being equal to input multiplied by the transfer function of the block. Ideate. The need for block diagram reduction technique is normally based on the multiple blocks, reducing multiple blocks into single block, or for convenient understanding, it may sometimes require to rearrange the blocks from its original order. For the calculation of transfer function, it's required to be reduced. The basic elements of block diagram: input R of S, output C of S, summing point, takeoff point, G of S, transfer function, and H of S, feedback. The block diagram is basically modeling of any simple or complex system. It consists of multiple blocks connected together to represent a system to explain how it is functioning. The transfer function is the ratio between transformation of output to the transformation of input when all the initial conditions are 0. A simple system is given as the input is R of S is given to the block G of S and the output is C of S. G of S is represented by C of S divided by R of S. A complex system consists of many number of G's and one feedback shift system H. Basic elements of block diagram. It comes summing point. These are the rules of block diagram reduction techniques. Combination blocks which are in cascade or parallel can be converted in this form and moving a summing point behind a block will give the output like this. Moving a summing point ahead of a block, moving a pickoff point behind a block, moving a pickoff point ahead of a block gives these types of reduction techniques. And this slide shows how to eliminate a feedback loop and swapping with two adjacent summing points. For example, test and evolve. Find the transfer function of the following block diagrams. A complex block diagram is shown in this figure. First, we are going to apply the rule that move pickoff point and takeoff point, and eliminating loop and simplified as like this. Moving pickoff point B behind block. In this, the blocks are reduced like this. Eliminating loop 3 gives the block diagram reduction technique. Here the 3 blocks are converted into a single block, and the transfer function Y of S by R of S is given as in this equation. Another one example. Eliminate loop 1 and moving pickoff point A behind block gives the block diagram reduced to the form. Eliminating loop 2 and using the rule 6, we get Y of S divided by R of S in a single equation. Thank you.